Hello! In this movie, we will show how to develop a distributed control system using the Remote Uniform Project Development technology. Our goal is to program logics in the ViewPAC Industrial PAC Controller, to develop embedded HMI for it, to connect the ViewPAC to the PC, and create an HMI application on PC by means of Remote SCADA HMI development software. For such purpose, we have assembled a system which includes a ViewPAC controller with I/O modules in slots and usual PC connected to ViewPAC via the Ethernet network. Our ViewPAC controller has the following IP address and contains I/O modules in slots as follows. In the first slot, analog to digital converter, 8 analog inputs. In the second slot, digital to analog converter, 4 analog outputs. And in the third slot, we have digital input and output module, 8 digital inputs and 8 digital outputs. We need to develop a logical program which will control digital outputs of the ViewPAC controller using language function block diagrams, and to visualize some analog and digital signals on VGA monitors connected to the ViewPAC and to the PC. And by the way, you must know that ViewPAC controller combines WinPAC controller, graphic display, and keypad in one unit. For your comfort, we will perform such development in 2 stages, and we will film it in 2 episodes. In order to develop this project, we will need the Remote SCADA HMI development system of the professional line and a Remote runtime for ViewPAC controller, micro Remote for Windows CE 2. We assume that the micro Remote has been previously written to the flash memory of ViewPAC. So, the first episode, ViewPAC programming. First of all, let's launch the Remote development system. And using the icon located at the left upper corner, we create a new project in a standard style. Let's start our project development from the layer Sources Receivers, where we describe analog and digital input and output signals located in I/O modules. For such purpose, we open menu using right mouse button and select group PC-based controllers. In this group, we create a new group OM WinPAC WinCon. And now let's place I/O modules to slots in series according to our task. First slot, the second slot, and the third slot. Draw your attention that ID creates hardware input-output automatically for selected I/O modules. This is a result of Remote auto-building technology. Let's click on the layer system and let's create a new node for our controller, embedded RTM. Then, by drag and dropping, we transfer I/O modules from the layer Sources Receivers to node embedded RTM one by one. The first, the second, the third. After this operation is done, we can see the Remote channels in the node embedded RTM. Since this module communicate to central process unit via internal serial network. Let's create a new group, COM ports. Let's open the port for editing and select host OEM assignment, and let's change exchange rate to this value. The other settings are kept unchanged by default. In order to connect our controller to PC via Ethernet, let's open the node embedded RTM for editing. Then we type the IP address and set flags reception and sending for the first network adapter. Now let's develop a program which will control for digital outputs in the 8054 model by means of the remote channel WinCon DO8. For such purpose, let's select the group channels and by means of context menu create a new component program. Edit it by double-clicking. In the script tree, select arguments and with the icon create, make one argument. Change the IO type to out and change the data type to unsigned int. Unsigned byte with 8 bits needed to control our digital outputs. Let's link our argument to channel WinCon DO8 by drag and dropping. Now the program's output argument will define channel's attribute input value connected to the port of the digital output inside the module 8054. In order to develop a program, we need to click to its name in the script tree. Let's select the language for development, function block diagram, and press OK button. By the way, you can use all 5 IEC languages to program the controller logics, and all these programs may be used in controllers and in PC also. Let's close Project Explorer and open FBD Blocks palette and Variables window. Our program will one by one turn digital outputs on from the first and up to 8th. Then turn off all outputs and repeat it from the beginning. Let's select the tab generators and transfer by drag and dropping the functional block bitminder to the editor field. Then drag and dropping increasing counter from triggers and counters, rise to a power and subtraction from arithmetic tab. By drag and dropping, connect functional blocks between them, assuming that block inputs are on the left and outputs are on the right. Now we compile the program by means of this icon and run the debugger and look at the window of variables for result. The program operation result may be seen both on the FBD blocks and in the window variables. Well, now we stop debugger and open the Project Explorer. Now all we need is to save our project on the disk with the name ViewPAC. Then using this icon, we save project for real-time monitor. It's necessary to do in order to run our project in the real-time mode under trace mode runtime software, micro trace mode. As a result, in the folder trace mode 86 was created a folder with project name ViewPAC, and inside it a folder with the name of the node embedded RTM. Here there are files with extension DBB and RTP which are needed to launch microtrace mode. Let's copy these files to the flash memory of ViewPAC, micro SD card, and then let's run microtrace mode in controller. Now we are inside the controller, micro SD card. Our files with extension DBB and RTP. This is micro trace mode for ViewPAC. Let's launch. By means of the main menu item File Open, our file ViewPAC. Press OK button. With the help the main menu item View, let's open channels. And with this icon, let's launch microtrace mode. Now we are in real-time mode. Analog inputs, analog outputs, our program. This is value on digital outputs. By the way, we can change any output channel by writing a new value to channel's attribute input value, and we can turn on off our program by writing values 1 and 0 correspondingly to channel attribute status. Analog output. Voltage DC. Analog input connected by wiring with the first output. We can see full correspondence. Program. Attribute status. Value 1 in order to turn off our program. And now, by sending value 0, we turn on our program. Okay. You can also use trace mode utility SPY for remote debugging of any project's node directly from the development system, but it must be connected via Ethernet. Thus, we have successfully implemented trace mode software to program and debug ViewPAC controller. We have spent only a few minutes for that. In the second episode, I will show how to make an embedded HMI in ViewPAC and full-featured HMI on PC. To be continued. See you!